2, lesson 25, finding measures of central tendency and dispersion. Most of these are really easy. They're ones that you know. They're things like mean, median, mode, and range, right? We're familiar with those types of things. But we're going to also talk about things like variance and standard deviation, which might be new to you, okay? We'll show you how some of those equations play out and how to do a lot of that in your graphing calculator, where your graphing calculator shows that information. Statistics is the branch of mathematics, not the breach, but let's try to fix some things in here. Branch of mathematics that involves the collection, analysis, and comparison of sets of numerical data. A measure of central tendency is used to represent the middle of a set of data. Central tendency, middle. Okay. Don't think there's anything else on that page. Moving on. Mean, right? We know what mean is. What's another word for mean? Average. How do we find the mean of a set of data? All right, add up all of the points of data and divide by however many, the number of numbers that there are. That's absolutely right. What is the median? The middle number. But are there any qualifications for that middle number? Can I take my data, just put it all in a line, and find the middle one? What does it have to be, Eric? It has to be in order from least to greatest. Okay, so it's got to be in numerical order as much as it is possible. Okay, it doesn't have to be 1, 2, 3, 4, but it does have to be in order from least to greatest, and it's the middle one from there. Well, whenever I get to the middle, I find that there's not one number that's in the middle, but two numbers kind of fit the middle. Average those two numbers together, meaning that you're going to add those two numbers together and divide by 2, because there's only two numbers. Okay, so that's the median. The mode. Mode is what? Most number. The number that shows up the most in the data. What if there's more than one? Do I list them both? What if there is none? Then there's nothing there. Okay, so we're good. All right, so we understand those. A measure of dispersion is a statistic that indicates how spread out or how dispersed those data values are. I don't often show you guys just because I feel like sometimes it could be a breach in somebody's information or whatever, but we can look at data in terms of our test scores and see what that data looks like in terms of dispersion. I might be able to pull up one here if I still have any of them. Let's look at if this will pull up. We'll see it here in a second. It may just take a little while because you can see that I have 1,000 tabs open, so my internet's not super quick. Okay, so here's a geometry test from, actually it's not what I want to look at. That's the actual test itself. Let's find something else. I want to be able to show you the data, and we'll see how spread out or how clumped up it is. Okay, let's try this one. Okay, here we go. This was a SMART goal quiz that was given to Algebra 1. All right, do you see how we have dispersion in here? We have average, which is our mean. We have a median, the number that would have been in the middle, right, whenever we calculated it all up, and we've got our range. Our range goes from somebody who scored 2 all the way up to somebody who scored 5 points. All right, you see that it's not... do we have an outlier, right? Do we know what an outlier is? Right, an outlier is a set of data that's either, way low or way high. Do I have an outlier here? Kinda, right? Which one would count as my outlier? The one person who got a 2. Okay? Everybody else is kind of clumped up at 4 and 5, correct? Okay? So that's what we're talking about when we're talking about dispersion, is how spread out or how clumped up the data is. Okay? Let's see, I don't know. No, that won't work either. Okay, so we'll back out of that. All right, which brings us with measures of dispersion. Range is the difference between the largest and the smallest data value. So I take my number with the greatest value, I take my number with the smallest value, and I subtract the smallest from the largest, and that tells me what my range is, right? In that SMART goal quiz, I would take 5 minus 2, right? I've got a range of 3. There's not a whole lot of questions there. We would probably get more interesting data if we looked at a full-fledged test where we had 18 to 20 questions, something like that. Standard deviation, though, is kind of new information to us. Okay, standard deviation measures on average how far from the mean the data values are. The standard deviation is shown by this sigma symbol, which it's like a 0 or an O with a hat on top of it, which is the Greek letter sigma, is calculated using this formula. So it is the square root of each number minus the mean value squared plus each value minus the mean of the data squared plus the next value minus the mean of the data squared until I've got all of the points of data minus the mean squared, and I divide that by however many points of data I have. And then what that does is it gives me the average distance that each number is from the average. You see do you kind of understand that a little bit? Okay. So we'll see some questions that'll work with that. We'll work out how to do that pencil paper, and then we'll show how to do that much quicker with our graphing calculators. Okay. All right. So standard deviation. An outlier is an item in a data set that's much larger or much smaller than the items in the set. The presence of an outlier in a set of data can have a misleading effect on the measures of central tendency and dispersion. For instance, if I have, okay, so let's take that number 2, right? I got everybody at 4s and 5s, and I got this one person who's at a 2. What did that 2 do to the average? It lowered the average. Okay, so if I have an outlier that's really low, it's going to bring the average down. What if I have an outlier that's really high? Brings the average up. Okay, now an outlier will always do the same thing to the standard deviation. It will always increase the standard deviation because standard deviation is distance from the average. So it's distance, so it doesn't matter if it's low or high, it increases the average distance of the data from the average. Do you follow me? Okay, so you'll get a question like that on a test or quiz or maybe even in our homework where it's going to say, hey, here's a data set, right? Here's a whole bunch of data, identify the outlier, okay? And then it's going to ask you, what did the outlier do to the average? Did it bring it up or did it bring it down? Okay, so it lowered the average. All right, but an outlier will always increase the standard deviation. Always. Okay, because it's changing the distance, it's increasing the distance because it's either way high or way low. Okay? All right, I think that's it for that. Let's look at some questions. Okay. All right, so asteroids, we see all this kind of stuff in here. The asteroid belt is a band of asteroids that lies between the orbits of Mars and Jupiter. Suppose scientists measure the diameters of several asteroids. We want to find the mean, median, and mode of the data round to the nearest tenth if necessary. Well, how many points? We've got 9 points of data here. We could add all of those up, divide by 9, get our mean, right? We would have to put them in order from least to greatest, get our median, look through here, see if we can find a mode. Mode's probably the easiest, right? Can anybody tell me what the mode is? 96, so that at least gets me something, right? But I see that I have 3 of them that are 96. Is there a faster way to get my data? Yes. Okay, and I'm going to show you. Does everybody have a graphing calculator on hand today? Everybody's picked one up. Great. All right, so let's get in here. All right, and I want to do something before I get started, okay? And I want everybody to do this before we get started because we're going to need this later. We're going to hit second, and we're going to come down here and hit the 0 button because we want our catalog. Okay, is everybody there? All right, we're going to hit our arrow down button, until we get into the D's, and we want to find something called diagnostic on. Because that's essentially what we're looking at, is we're doing a diagnostic of data. All right, and we're going to hit enter and enter again. You might have to hit enter multiple times if you have a newer calculator. And Axel, with that calculator, until I look at it, I'm not necessarily sure what that you need. What's that? Yeah, it's not really worth it to mess with it. And it might go ahead and it might have that data in your TI Inspire. Okay, so what we're going to do from here is we're going to go to stat list. All right, and we're going to edit. And all of our information here is just one list, right? So we're just going to go ahead and type in our data: 55, 15, 96, 21, 90, 96, 43, 35, 35, and 42. Okay, and notice if you look down here, that's it. Okay, here, give me a second, I'm going to pause. Okay. All right, so from here, what we want to do is we're going to hit stat again. We're going to go over to calculate, and we want one variable statistics. Notice that a lot of the stuff that we use is right up at the top. They're up at the top because TI understands that there's some things, the things that are at the top are the things that get used most often. Remember how, like with determinants, right? Determinants was like first thing, right? We didn't have to scroll down to find determinant. It's because that's what gets used. All right, so we're going to hit enter. We're going to hit enter again. All right. This compiles my data, and it gives me a lot of different bits of information. For instance, my mean is represented by X with a solid bar over the top, right? And it shows me that my mean is 54.8. Okay, are we good there? Now, my standard deviation is this right here. And so my standard deviation is 29.9. Okay, so it's not asking for that. But if I go down, and I keep going down, I'll get more data. Okay? And the rest of this data would give me information for like a box and whisker plot. Okay? So with a box and whisker plot, we have a minimum, we have Q1, we have median, we have Q3, and we have a max. But for today, we don't need all of that, but we do want the median, right? Which is 43. So I've got my mean, which is 54.8. I got my median, which was 43, and I could see the mode, right? Okay? And I don't know if it lists it or not. It doesn't. So it doesn't actually, it doesn't do the mode for you, at least not here, not where I see it. So do we understand how to get to this, how to get our data, how to find it, and use it? Yes? Okay. All right. So let's come out of here. All right, now on this next one, it wants the mean and the standard deviation. All right, so what do? We get our now we're going to do this one pencil paper, okay? So we want the mean and the standard deviation. So we need 1 plus 5 plus 8 plus 5 plus 1 divided by 5, right? 1 plus 5 is 6. 6 plus 8 is 14. 14 plus 5 is 19. 19 plus 1 is 20. 20 divided by 5 is 4. So mean equals 4. Okay, now we want the standard deviation. Okay, standard deviation is the square root of each number. Okay, so 1 minus my mean, 4 squared. Okay, that's the first one. Plus 5 minus 4 squared plus 8 minus 4 squared. Let's see, plus 5 minus 4 squared plus 1 minus 4 squared. All divided by 5. Okay, do we understand the different parts of this? Okay, so I'm going to try to simplify. 1 minus 4 is negative 3. Negative 3 squared is 9. 5 minus 4 is 1. 1 squared is 1. 8 minus 4 is 4. 4 squared is 16. 5 minus 4 is 1. 1 squared is 1. 1 minus 4 is negative 3. Negative 3 squared is 9. Okay. All right. Scroll down. Well, anyway. 9 plus 1 is 10. 10 plus 16 is 26. 26 plus 1 is 27. 27 plus 9 is 36. Right, and so we're going to wind up with the square root of 36 over 5. Okay, can we tell me what that is? What is the square root of 36 over 5? Okay, 2.68 is fine. So we're looking for the mean is 4, the standard deviation is 2.68. Okay, and so let's go ahead and try this in our graphing calculators. Let's make sure that our answer is right. Okay, so I'm going to go to Stat. We're going to go to Edit. Okay, and I'm going to put in my information. 1, enter, 5, enter, 8, enter, 5, enter, 1, enter, and I'm going to delete that one. I'm going to delete that one. Delete, delete. Got it? We hit Stat. We go over to Calculate. One variable statistics. Okay. My mean was 4. My standard deviation was 2.68. Which, I mean, I'm not telling you not to use pencil paper, but hopefully we could tell that our calculator can do a lot of this for us if we get used to this, right? And some of you guys want to take the ACT. You want to be able to do this, right? Okay. My ACT score skyrocketed after I had a teacher show me what my graphing calculator could do. My math score skyrocketed, okay, because suddenly I wasn't trying to brain force everything, right? I knew I had a calculator that could do a bunch of it, okay? So I wasn't racking my brain over how to do it. All right, let's look at this for a second. So now this is a lot of data. The number of calls received by a technical support center during 18 randomly selected days is listed. We want to identify the outlier, and we want to describe how it affects the mean and the standard deviation. Look through the data to see if you can spot the outlier. 14. Okay. Is it much smaller or much bigger than the rest of the data? Much smaller. So, what is it going to do to the mean? What is it going to do to the average? Is it going to increase it or decrease it, John? Decrease it. It's going to decrease the average. So what is it? I mean, if we look at these possible answers, okay, we know that the outlier is 14. Okay, outlier 14, which makes more sense that the mean would be 69.4 or that the mean would be 18.6. What makes the most sense for the mean for this data? 69.4, right? Because we look at all the numbers and you're in the 80s, the 70s, the 60s, the 50s, except 14, right? So basically is that it's going to bring it down, but it shouldn't bring it down a whole lot because it is an outlier, but it's in the mix of a lot of numbers that are all grouped up really close, all right? So it is probably going to decrease it more likely from 69.4 to 66.3 rather than it bringing it all the way down to 13.7, right? That's crazy. For one, can an outlier bring the average down to a number that is below itself? No, right? If I got a 23 on a test and the mean of the data is a 75, right? My score isn't going to bring it down to a 15%, right? It can't drop it, below where my score is. All right? Now, what does an outlier always do to the standard deviation? It always increases it. All right? So the other thing is the outlier in the data set causes the mean, to increase from about 13.7 to 18.6. Okay, now they kind of get that messed up. So the part that they really messed up, the difference between B and D, is that they've got the numbers representing the wrong things. Okay? Does that make sense on number 3? I bring that up because you'll see number 3 on a test. Okay? But I don't give very many points for it because people can't tell me why. Okay? You have to describe why B is the answer. Do you understand? I'm trying to give that information to you now. Okay. All right, you guys are out of here in just a couple minutes. Do we feel like we understand this? Okay, the last part that I need you to get, and we saw this with our information, right? And for some reason, it's not really in this lesson. The lesson doesn't talk about box and whisker plot. Well, it does. It shows it on page 182. Do we know where to find the box and whisker plot information? Okay, you scroll down. You find the minimum, Q1, median, Q3, and max, and you draw it based upon that. Okay, can we do that? All right, I'll let you guys go.